Okay, we're back. We are back. We're back. We're back. Are we back? Back. We're back. We're back. All right. So share the new link to. Devil is a liar. He doesn't want us to hold this class since yesterday, since last time. Well, we will continue either way. All right. So let's continue. Right. So share the link to. Devil is a liar. All right. So they said a ball is thrown vertically upward from the ground with a speed of, now this is on projectile. Okay, so let me just give you a brief note on projectile, what you just need to note on projectile. Okay, from there we'll know what to do, and um we can solve question on projectile. Now usually there's some formulas that you should note, formulas like these formulas, this v equals to u, or let's use v naught, v equals to v naught plus at. Okay, these equations of motion formulas, S is equals to V naught T plus AT square over 2. We know we know that V square is equals to V naught square plus 2AS. And we also know that S is equals to U plus V over 2 times T. Okay, over 2 times t. So we're going to be, this is the formulas we use for projectile. You may be shocked that projectile should be is all those ones that used to have t equals to u sine u square, all those ones, u sine theta over g, u square sine square theta over 2g. Yeah, those formulas are actually legit formulas. Okay, but usually I love solving questions on projectile using our normal equations of motion. Our normal equations of motion. Are we together? So let me show you how it is done. And the thing here is that for projectile, what we do is to resolve. Is to do what now? Is to resolve. I believe you remember resolution of vectors. Very soon I'll be dropping a video on that, on scalar and vectors. You can go to the page and check the playlist. You see the first video I dropped on scalar and vectors. So I'm dropping more videos on scalar and vectors. Okay. When we talk about resolution of vector, we mean that we can split up a vector into two components. Okay, we can split up a vector into two components. For example, you something like this, you see something like this, something like this. Okay, this is called the x component, this is called the y component. Let us now have a vector. Okay, this is a vector. The vector, obviously there should be an arrow sign, so this is a vector. Let's call the vector v, for example. V for velocity is a vector, right? Good. So I can resolve, if this v is making an angle of theta to the horizontal, I can resolve this vector to the x component, we call that the vx, and the y component, we call that the what? The vy. So mathematically we know, I think everybody here should know, that vx is v cos theta. All right, and vy, if you know about this, just you don't need to worry much about it. It's very simple formula. Vy is equals to what? V sine theta. So I'll be releasing videos on this very soon. Just note that the x component of the vector is v cos theta, that's the vector cos theta, and the y component is the vector sine theta. So note this as well, because we're going to be using this a lot. Note this as well. Now I can rewrite this formula, these formulas here, I can rewrite it in terms of resolving the vector to horizontal component and vertical component. Okay, let's start with horizontal component. Let's start with horizontal, or what should I write this? Let's write it down here. Let's write it down here. Let's start with horizontal, horizontal components. Horizontal components. So I'm going to rewrite these formulas here. this formula as v equals to u plus 80. I'm going to write them in terms of component vectors. We can resolve velocity to x component and y component. We can resolve v naught to x component and y component. We can resolve what a to x component and what and y component. Do you understand? So if I'm to rewrite the formula v equals to v naught plus 80, what's it going to become? It's going to become what? It's going to become Vx equals to V naught x plus axt. Now I'm resolving this now to the what now? To the horizontal component, okay? Let me write it by the side here. For the vertical component, for the vertical component, for the vertical component, this V equals to U plus 80. What's it going to be? To become Vy, that's for the y component, is equals to V naught y plus AYT. I think this makes a lot of sense. This makes a lot of sense. Okay. Let's see the second formula. The second formula we have here is S equals to V naught T plus 80 square over 2, right? I can write this as, let me write it up here. S equals to V naught T plus 80 square over 2. Let's resolve everything here to the x component. This s is distance. So distance in the x component is represented as what? As x. So x is equals to v naught in the x component to be v naught x. Okay. Then t plus a in the x component to be a x t square over 2. Am I communicating? Y for I didn't use the right color, so let's put that in the right color. Let me just write that real quick. So x will equals to v naught xt plus ax t square over 2. Let's write the same formula in y component. So what's going to be now? X in the y, that's the distance in the y component, is y equals to v naught in the y component is v naught y, okay, then t plus a in the y component is a y t square over 2. I think this is making a little bit of sense. The next formula we have v square equals to v naught square plus 2as. Let me write it up here. I have v square equals to v naught square plus 2as. Let's write this again in terms of x and y components, shall we? So this will become this v here in the x component will become vx. So vx square, okay, equals to this v naught in x component will become v naught x square plus 2 a in the x component will become ax, then s will become what? X. You understand? So for the y component, v will become vy. So this is going to become vy square equals to v naught become v naught y. I think you get the idea now. Plus 2a will become ay and distance will become y. So it's just like normal equation of motion, just that I'm just resolving the vectors to x and y components. I'm resolving the vectors. That's vectors we have. You can say I didn't write anything like ty and tx because t is not a vector, it's a scalar. I'm only resolving the vectors to the x and y components. So these are our formulas. If you realize these formulas are not something that you should cram, the normal formulas that you know, do you understand? It's just that I'm only resolving them to x and y components. So that whenever you're solving a question on projector, you have to note the components that projector is acting on. Okay? Note the note the what I say again. Note the components that have that question or that vector is acting on. So note one more thing before we start solving is that a in the x direction is 0. Okay? That means that everything here becomes 0. Do you understand? So we're going to be having v x equals to v naught x, and also everything here becomes 0 as well. So what's it going to be now? Here we'll now be having x equals to v naught xt. All right. So and also note that ay is also equals to g, not 0 is equal to g, because when the body is thrown up vertically upward like this, okay, when the body is thrown vertically upward, or when the body falls from a particular height, as far as it is vertically or at a particular angle, doesn't matter. In this case, a is ay, okay, and ay is g. When the body is falling, ay is g, which is 10 meter per second square. But when a body is thrown up, ay is minus g. Do you understand that? That's minus 10 meter per second square. All right, and having noted this, I think we can solve questions now. So let's play with this question. The question says a ball is thrown vertically upward from the ground with a speed of 20 meter per second. So we're given the v, but this is the v naught, isn't it? We're given the v naught. That's the initial velocity now is 20. So v naught is equals to 20 meter per second. All right, but this v naught is in which direction now? It's not in the y direction. It's not in the y. They said it is thrown vertically upward from the ground, so vertically upward. So this v naught now is in the y direction. Do you understand? How long does it take to reach its highest point? How long does it take to reach its highest point, and how high does the ball rise? How long? We're looking for time, the time it takes to reach to get to the highest point. Class, at the highest point, the velocity of a body, okay, at the highest point is 0. Okay, velocity of a body at the highest point is what? 0. This velocity, am I dealing with the x or y axis? The y axis, so I'll put a y here. Do you understand? Also, what else do we have? A body is thrown vertically upward. That means that we're given a mystery value. We're given ay, and ay is g, which is what? 10 meter per second square. But the original value is 9.82 meter per second square. I don't know if I'm communicating. Please, if you are getting what I'm saying, simply drop a like or a thumbs up. So we continue. So how do we solve this? We have V, we have V naught, we have A, we have T. From the traditional formula, we have V equals to V naught plus AT. If I write this now in the X component or in the Y component, yeah, I'm doing the Y component, Abby. So let's rewrite everything here. Let's write it now in the Y component. So what's going to be? Become Vy equals to V naught Y plus AYT. It's very, very easy to get the formula. You can see that this is it over here. It's very, very easy, and very, very easy to get the formula. Okay, so let's go. So what is Vy? Vy is 0, right? So 0 is equals to, what is V naught Y? V naught Y is 20. 20 plus, what is my A? What's my AY? My AY is G. But now this body is being thrown up, Abby. Without, let's say that the body is thrown vertically upward. So it is thrown vertically upward. It means that A is not just G, but what? Minus G, which is what? Minus 10 meter per second square. So the value here will be having um minus 10 times T. So therefore, we solve in mathematics, bring this over to bring it over to this point. We're going to be having 10t equals to 20. So divide both sides by 10. My t will be equals to what? 2 seconds. Very, very sweet and simple. T equals 2 seconds. T equals what? 2 seconds. So which of them have 2 seconds? So sometimes you just have to be smart in your exam. The answer is obviously B. So if students want to continue to solve, they want to solve and get the final answer. The answer is obviously there is B, since we're seeing 2 seconds and that's the only one that have 2 seconds. So that's the answer. But if you want to calculate for the they said the how long does it take to reach its highest point? How long? We're looking for the time. Let me clear. I don't even have much space on my board anymore. So let me clear up some space. Let me clear up some space. Clear all this up. Okay, so let me solve it here. Let me clear this also. We don't need this anymore. So we have to find what? We have to find how. We have found how long already. We have to find the um Okay, and how high, so we're looking for distance. Distance in what direction? Y or X? Is Y. So I'm obviously I'm looking for what? For Y. So what's the formula? What formula has distance in it? Don't forget the formula that says that S, the one you know, V naught T plus AT square over 2. When I'm dealing with the y-axis, so I can rewrite this formula in terms of y-axis. So let's go. What's going to be? What's going to be? It's going to become, do I have V naught? I have V naught. So it's going to become Y equals to V naught Y T plus A Y T square over 2. Very, very basic and simple. The main basic thing here is just to express the normal equations, in terms of y-axis and x-axis. So let's go. I'm looking for y. So y will be equals to, we're giving v naught y. V naught y is 20. So 20 times, we're giving t. Yes, t is 2. All right. Then plus ay. What is value for ay? Ay is minus 10. So this will give me minus here. So minus 10 times t is 2. So 2 square will give me 4 over 2. 2 can go here to give me 2. So my y will be equal to 2 times 20 times 2 will give me 40 minus 2 times 10 will give me 20. This will give me 20 meter. Very simple. You can see that the answer was actually correct. Answer was actually correct. All right. Again, I said do well to share the new link to your friends so they can join the new live section. Do well to share the link to your friends. Share it. If you've not shared it, do well to go back to your WhatsApp or your social media and share. And after the class, I promise this class will be recorded. This class will be recorded, so you can always share the recorded link to them, let them watch and learn as well. So let's go straight to the next question. The next question. I hope this part is clear. I hope the formulas are also clear. So I want to wipe out the entire screen now. So I hope the answers are clear as well. So let's move on. Let's move on. Okay. Next question. Next question. I said the acceleration of a moving body is equal to dash. Now, talking about graph here, okay? So note that we do something we call a time graph, okay? Something like this, something like this. This is like a graph, okay? The y-axis we have the velocity, x as the unit is in meter per second. Here we have the time, unit is in what? Is in seconds. So we call this the velocity time graph. Okay, so there's some lines that you should note here. So let me just quickly sketch that out. Some lines you should note. When you say line going up like this, okay, we say this here is uniform acceleration. When you say a straight line going up, okay, when you say line going straight like this, is not increasing, just like this, we say this here is uniform, or you can say constant constant velocity. Okay, when you say line coming down, we say this is deceleration. So we say uniform deceleration or uniform retardation. There are three lines you should note in velocity time graph: uniform acceleration, okay, constant velocity, and uniform deceleration. So the slope, or you can say the gradient, or slope of of a velocity time graph, okay, is acceleration. Is what? Acceleration. So you can note this. The gradient or the slope of a velocity time graph is what? Is acceleration. I can prove it to you. I can prove it to you. What's gradient? Let's do something crazy. What's gradient? It also means slope, abi? And what is slope? From our secondary school, we know that slope is change in y over change in x. Now, what is change in y? What is the y as it says? It's not velocity. I can say change in velocity, abi, over what is the x-axis? It's not time, change in time. Now, we just finished talking about some calculations on kinematics. What is change in v over change in t? Isn't that acceleration? It is what? It is acceleration. That's correct. So, the gradient of a velocity time graph is acceleration. Is acceleration. All right. What is the question saying? It said the acceleration of a moving object is equal to the gradient of displacement time. Is that correct? That is not correct. The area below the displacement. And okay, let me just tell you the answer to this one. The gradient of displacement time is actually velocity. Okay, is velocity. It is not acceleration. The area, the area below displacement time graph, the area below is not, that one is just distance covered. Okay, distance covered in under a displacement time graph. Okay, this area below speed time graph is also talking about. This speed time graph is not same as velocity time graph because acceleration is a vector quantity, so you cannot say speed time. So this is actually what? Very wrong. So the gradient of a velocity time graph, yes, this is the answer. The gradient of a velocity time graph. Some people want to go for C, but know that speed is not a vector quantity, but acceleration is vector. So we have to go for what? Velocity and not speed. All right, next question. All right, next question. So a car decelerates with 10 meter per second square. Decelerate. Now note that acceleration is negative of deceleration. Okay, so if I want to represent this with acceleration, I can say acceleration A is negative 10 meter per second square. Because acceleration and deceleration are like negative of each other. Do you understand? And decelerate from what to what? From this to this. So what's the initial velocity? V naught is 50 meter per second and V is 20 meter per second. Calculate distance traveled by the car. Distance traveled. So I'm looking for the distance traveled. Obviously the car is traveling the x-axis. So but this is not, they didn't talk about throwing an object or anything. So this is not actually projectile. So let's just write that as what? As S. So what formula has all these quantities, has all these things? We have a formula that says that V square is equals to V naught square plus 2as. Okay, we can use this to solve for the value of s. So v is 20. So 20 square is equals to 50 square plus 2 times minus 10 s. Isn't it? Since a is minus 10, so this will give me 20 square is 400 equals to 2500 minus 20s. So collect like tens, bring this here and take this over here. You're going to have 20s is equals to 2500 minus 400. So therefore 20s is equals to 2100. Divide both sides and divide here. 0 will cancel 0. 2 here will give me 105. So S is equals to 105 meter. S is equals to 105 meter. Option B. Option B. Okay. Next question. All right. Next question. Okay, I think we are making good progress now. Let's see this question over here. The question says Now, I know that all the questions I've been solving so far are from Adewale Physics. Okay, they are all from Adewale Physics. Okay, so a car accelerating uniformly in a straight line with all these are simple questions. It's only in a straight line. Okay, in a straight line with acceleration of 10 meter per second square. Acceleration of 10 meter per second square. Okay, so what we have to find? What we have to find? I think I'm thinking of giving you a little time to solve this, but I don't know how much time we have. So I think I'll just solve it. Okay. Or if you want to attempt it, you can attempt it on your own while we are solving here together. Okay, so we're told that the car accelerating uniformly in a straight line with acceleration of so the acceleration of that car A sorry acceleration A is 10 meter per second square and travels 150 meter. The distance that that body or that car traveled, that's x, because it's moving the x direction, is 100 and what 50 meter in time interval of 5 seconds. So the time it used to travel was what now was 5 seconds. So how far will it travel in the next? Okay, how far will it travel in the next 5 seconds? How far will it travel in the next 5 seconds? That's two ways of thinking about it. We can calculate it. We don't have seconds, have we? So what is the distance it travel in the next five? Okay, that means the distance traveled in 10 seconds. We can say this is the next 5 seconds is the distance traveled in 10 seconds, okay, minus distance traveled in 5 seconds. I don't know if this makes sense. So the distance traveled in the next 5 seconds, okay, the distance traveled in 5 plus 5 will give me 10 now. So distance traveled in 10 seconds and distance traveled in what? In 5 seconds. Fortunately, we already have distance traveled in 5 seconds, which is what? 150 meter. So we need to find distance traveled in what now? In 10 seconds. All right. So what formula, what values do we have? What values do we have? What can we use? What can we use to find this? Okay, we have a formula that says that S is equals to V naught T plus 80 square over 2. Okay, I have my time to be 10 seconds already. I'm trying to calculate distance traveled in what now? In 10 seconds. I'll now subtract my answer from distance traveled in 5 seconds, which is 150. Then whatever I get is my answer. What do I have? I have T to be 10, I have A to be 10, but I don't have V naught. So we have to find V naught. How can we find V naught? From this previous value, I can use this previous value to find the initial velocity of that car. Okay? Okay. So we know that S is equals to V naught T plus 80 square over 2. All right. So what's our X here? 150 is equals to V naught times T, which is 5 V naught, plus A is 10. A is 10 times T is 5. So 5 square give me 25 over 2. So give me 150 equals to 5 V naught plus simplify 250 divided by 2. You have 1 to 5. Just give me 1 to 5. So when you rearrange, you'll be having 5 V naught equals to 150 minus 1 to 5. That should give me 25. So my V naught divided by 5, you have 5 meter per second. So this is the initial velocity at which the car started to move. So we can impute this here. So we're going to be having x to be equals to 5 times 10, since time taken is 10 seconds, plus a is 10 times 10 square over 2. So punch this into your calculator, and give me a sec to punch. So calculator, you get 550. So give me 550 meter. Now don't get confused. That is not the answer. That is not the answer. I said distance traveled in the next five. So distance traveled in the next five is distance traveled in 10 seconds and distance traveled in what? In 5 seconds. That will give me 550 meter minus 100 and what now? 50 meters. So our answer here should be 400 meters. Should be 400 meters. Let's see the options. Yes, option B is correct. Option B is correct. Are we still here? All right, next question. The next question. Oh, the next question. Let's see. Let's see this. Okay, let's see this. Let's see this question. What does the question say? Say calculate the time. It says calculate the time taken and distance covered by a train moving with a velocity of. Okay, the train is moving with a velocity of. This question are just too simple. Maybe I think there are some tougher ones here. Maybe I'll pick that next. So the train is moving with a velocity of this. So that's the initial velocity of the train V naught, which is 15 meter per second. So accelerate uniformly at the rate of at the rate of 2 meter per second square. So acceleration A is 2 meter per second square. To reach a velocity of, since reaching a velocity, that means V is equal to 20 meter per second. All right, the say should calculate the time. So I'm looking for T. So before I solve, can anyone just give a little, um, quickly solve this and tell me your answer in the next 10 seconds. All right, has anyone solved it? No one has solved it yet. Wow, it means that we are not active. Okay, so let's solve it together. So T, as to find T, what can we use? We know that V is equals to V naught plus 80. So our V is 20. So 20 is equals to 15 plus 2T. So bring this over here. We're going to have 20 minus 15 will give me 5 equals to 2T. Divide both sides by 2. My T will be equals to 2.5 seconds. So our answer is either A or D. So let's find the other part of the question. What does that part say? It said find the time and distance. I'm looking for distance now. So let's find the distance S. Let's find distance S. Let's find the distance S. What can we do? We know that V square is V naught square plus 2AS. You need to know these formulas by heart, okay? What is V? V is 20, so that's 20 square is equals to 15 square plus 2 into bracket. Were we given A? Yes, that's 2 times 2 times S. So 20 square is 400, 15 square is 225 plus, this will give me 4S. Maybe for S, don't forget. So bring this over here. We have 400 minus 225. That will be 175 is equals to 4S. This is S, not 5, please. So divide both sides by 4. So my S, that's distance covered, is 175 divided by 4, which is 43.75. So our answer is D. Next question. Next question. Okay, let's pick this. I've not seen questions on projectile yet. Okay, let's pick this. It said a ball was thrown from the ground and its velocity was 10 meter per second. So it was thrown from the ground. Okay, so that means it was thrown up. Okay, at an altitude of 15 meter above the ground. So it was thrown with this velocity. It was thrown with this velocity. Okay, so that's the initial velocity, v naught. That is 10 meter per second. And what's the altitude? The altitude of also means the height at which the ball attained is 15 meter above the ground. That's distance. But that distance is in the y direction, Abby. So y is 15 meter. Then velocity at the point of throw. Right velocity at the point of throw and the maximum height is the velocity at the point of throw. So the ball was thrown from the ground and the velocity was that. So at the point of throw, what is the velocity? Does that mean that this is not the initial velocity? They said, listen to it again. A ball was thrown from the ground, and I want our input, please. This is a live section for a reason. So I want our input. Okay, a ball was thrown from the ground, and its velocity was this. This was velocity. That's after it was thrown. So you have to find the velocity at the point of throw. So that means this is not the initial velocity. If you want to try this out, I think most of us are not active. Well, okay, I'm giving us 2 minutes. 2 minutes. Try this out in 2 minutes. 2 minutes. But let's just make it 1 minute. 1 minute is enough to solve this question. So make it 1 minute. Okay, we have 30 more seconds. We have 30 more seconds. 30 more seconds. Okay, someone has dropped an answer. D, is it for the previous question or for this question? Okay, 10 more seconds. One, two, three, four, five, six, seven, 8, 9, 10. Okay, I'm solving. Okay, I'm solving. I said, from the look of the question, say the ball was thrown from the ground and its velocity was this. So that's the velocity of the ball. V is that. So and the altitude, that's y is that, and that was clear. So above the ground, calculate the velocity at the point of throw. So I'm looking for velocity at the point of throw, which is initial velocity. Okay. Okay, let's find out before we find the maximum height. And when a body is thrown, I told you that A is equals to what? Is equals to AY, which is equals to what? G. And G is equals to 10 meter per second square. How is this body moving? It's moving on the y-axis, Abi. So I write y here. I also write y here. Our formula has v naught, and distance a. So that's v square. Formula has v square equals to v naught square plus 2a s. So let us write this in terms of y components. So what's going to be? That will be v square y abi equals to v square not y. You can just put y everywhere plus 2ay the distance becomes what? Y. All right. So let's go. I'm looking for this. So my Vy is 10. So that will give me 10 square equals to V not Y, which I'm looking for, plus 2 times what is my A. Again, the body is shown, is not dropped. So in this case now, in this case, what do you think the velocity will be? So it was thrown from the ground. So that means that this A is negative. Okay. That'll give me times minus 10 times what is my Y? 15. All right. So this will give me 100 equals to V naught Y square. Everything here should give me, let's do the maths. 10 times that will give me 150 times that should give me minus 300, if I'm not mistaken. So bring this over here. It's going to become 100 plus 300, that is 400, equals to V naught Y square. So I can take square root of both sides, and my V naught Y will be the square root of 400, which is what now? 20 meter per second. So let's come back to the question. Which one has 20 meter per second? The answer is obviously B. Someone said C. Okay, let's see. Let us find the maximum height reached to confirm if B is the answer. Let's. Okay, you've changed your answer to B. Nice, nice. Okay, so let's see. They said calculate the maximum height. The maximum height reached. This Y here is not the maximum height. It's just the particular height at the particular point. Let's find the maximum height reached. So I'm looking for what? Y. All right. At maximum height, note something. Height, as maximum height, V is equals to 0. Just note that. As Vy, obviously, is equals to what? 0. All right. What can we use to solve this question? The body is dropping. The body is dropping from the maximum height. So Vy, V there is 0. And what else can we say? A A is AY, which is what? 10 meter per second square. In this case, the body is not being thrown up, but the body is coming downward. So that's why my A is AY. Or did they mention that the body is going up? Okay, the body is going up. So we're not considering the body coming down. All right, so that means our A is still minus. We didn't talk about the body going down. They only talk about the body going up. So that means that A is still what? A is still minus. So let me put that up. A is still minus. It's still minus AY, which is minus 10 meter per second square. So let's solve. Our formula we can use the same formula for the ones we use up here, which is V square equals to V naught square plus 2 AY, right? So we have our Y, and our Y. So our Vy is 0. So 0 is equals to our V naught initial velocity. What's initial velocity? Now this becomes the initial velocity. Do you understand? But the body was thrown. Body was thrown without velocity. So initial velocity there is 20 square plus 2 times minus 10 times Y. So 0 is equals to 400 minus 20y. So take this over here. You have 20y equals to 400. Divide both sides by 20. And my y is equals to 20 meter. So that means that the answer is B. Any question on that? Any question? Any question? All right, next question. Next question. Next question. I don't think we're able to solve this. This question are very, there are lots, so I don't know how we are going to stop today. So let's just keep on going. Let's see this one. So a man throws a ball vertically upward with an initial speed of this question is too simple. Initial speed of that. So the initial speed is thrown vertically upward. So initial speed as V naught. So V naught but y now because in the y-axis is 40 meter per second. So what is the velocity of the ball on hitting the ground? So it was thrown vertically upward. So that means the ball will first go up. The ball will first go up like this, the particular point before coming down again. The first go in this direction before coming down. Do you understand? So we have to find what do we need? What do we need? We need to find the time taken for it to go up. Do you want to try this? You want to try this question? Will anyone try it here? Or should I just solve? Will anyone try it? If you want to try, just signify. Just signify. And nobody wants to try it. Okay, if nobody wants to try, let me just save our time and solve. Let me save our time and solve. We're looking for the velocity at which it's used to strike the ground. So the velocity at which the ball used to strike the ground from this point is coming down to this point. Okay. So first. Can you hear me? Can you hear me? Can you hear me now? All right. So this will be equals to V naught is 40. So 40 minus 10 times t. So 10t will be equals to 40. So my t will be equals to what? 4 seconds. That means it took 4 seconds for the ball to go up. So at what? 4 seconds for the ball to come down. So the ball is coming from a particular height and it's coming to the ground. It's coming to the ground from this height now. The time taken for it to come down, the time taken, we just solved that and we got what? 4 seconds. Okay. Now we know that it's coming down now. So that means that it's coming down. That means that A is G, which means is what? 10 meter per second square. All right. What else do we know? What else do we know? What now is what is zero? But the body has gone to rest and is starting from rest. Okay. So our formula again is V equals to V naught plus AT. So our V is what I'm looking for. Our V naught is zero and plus A. Can you hear me now? Can you hear me now? If an object on the surface of the moon has a velocity of 10 meters per second at a height of this above the moon surface, what is the speed the object takes to strike the moon? Can you hear me? All right. So we're given the velocity. Given the velocity, surface of the moon has a velocity of this. So is 10 meter per second. All right. So we're given the velocity of the surface of the moon to be 10 meter per second. So that is the initial velocity. Okay. I said, what else? I said at a height of 120 meter above the moon's surface. So that means that this one on the y-axis is 120 meter. You're taking the moon's gravitational acceleration to be that. So a on the moon, okay, a on the moon. Well, obviously that is ay. That's giving 1.6 meter per second square. With what speed does the object strike the moon? I'm looking for the speed v, which the object used to strike the moon. That is vy. All these are in the y direction. Okay. So what will be my formula? My formula is going to give me v square equals to v naught square plus 2ax, but our x now is y, so 2ay, put your y, your y, your y. Okay. So I'm looking for this. So vy all square is equals to v naught y is 10, so that'll give me 10 square plus 2 into bracket 1.6 times 120. So v square in the y direction is equals to 100. So let's multiply this. 1.6 times 120 times 2 will give me 384. Everything here should give me 484. So if we take square root now, square root of that. So let's see. Square root of your answer should be 22. So the answer here is 22 meter per second, which is B. So the answer there is so next question. Next question. Let's solve this. So a stone is thrown vertically upward with an initial velocity of this. The stone is thrown vertically upward. Sorry about the sound on the screen. My mic just went dead. Okay, so a stone is thrown vertically upward. Initial velocity of 20 meter per second. So initial velocity, that's v naught. is 20 meter per second. So it's thrown vertically upward, Abi. So that's in the y direction. So find the time taken for the stone to reach its highest point. Time for the stone to reach its highest point, and the highest point velocity of a body at highest point is what? Zero. Do you understand that? Okay, let's solve for this. A A is obviously minus G. The body is going upward, so that's AY. That's minus 10 meter per second square. So what can we use? We can use the formula V equals U plus AT. As V equals V naught plus AT, that's V is equals to V naught plus AT. I believe now I'm putting Y because it's in the Y axis. So let's solve. So this is 0. So this will be 0 equals to 20 minus 10t. So 10t will be equals to 20 and my t will be equals to 2 seconds. So our answer here is D. Our answer is D. So moving on to the next question. We're still very far behind. Next question. Let's look at this question. Let's take a look at this question. It says that a mango is dropped from a tree. A mango is dropped from a tree 80-meter high with a zero initial speed. And it was dropped with a particular speed. Okay. So I can say here, let's write out the values we have. First, we have that the mango is dropped from a tree. So, and the tree is 80-meter high. That's in the y direction. So that means that y is equals to 80 meter. Okay, with a zero initial speed. Zero initial speed. Zero initial speed. Okay, let's say 1 second later. Okay, we have a stone or a was this? Okay, mango. A mango. Let me draw that. Let me draw that. This is mango. I can't really draw. So, it's a mango fruit. Okay, it was dropped. Okay, now say 1 second later, another coconut is dropped. So we have another fruit here. Let me draw that here. So it's a coconut. It was dropped. It was thrown vertically downward. Vertically downward. One thing that they both have is A. So A here is G. That's AY is G. And also here, AY is also equals to what? G. Okay, they said if both fruits strike the ground at the same time, that means the time taken for this, the same time taken for this to fall. Okay, they said they drop at the same time. Okay, they have different times. They release at the same at different time, but they dropped on the ground at the same time. They said calculate the initial speed with which the coconut is thrown. So we're looking for the initial speed. You're looking for V naught at which this one was thrown. Alright, so how do we solve this question? How do we solve this question? Let's say they strike at the same time, Abby. So I can calculate the time taken for this one to strike. So we can know the time taken for this one to strike the ground. Do you understand? So let's find the time taken here. Okay, so we have time. We have AY to be G. What else? What else? What else? What else? How can we solve this? The initial velocity, this body was dropped. They said the mango was dropped. So that means the initial velocity of the mango fruit was what? Zero. So we can use the formula y equals to V naught t plus a y t square over 2. All right. But we have a better formula. Let's use this formula. So our y is 80. So 80 will be equals to v naught is 0. So everything here will give me 0. Ay will give me 10. That's g. That will be 10 t square over 2. 10 t square over 2. So if you divide this, you'll be having 5 So 80 is equals to 5t square. Divide both sides by 5. My t square will equals to 80 divided by 5. That should be 16, I guess. That's 16. That's 16. Yes, 16. So my t now should be 4 seconds. Okay. So that means that this stone dropped, time taken for the stone to drop to the ground is 4 seconds. Okay. So time taken for this one is equal to time taken for this one. They said that here, took the same time. But don't forget that the coconut was released 1 second later. Which means the time taken for the coconut to fall will be 4 minus 1. Normally, they said that the time taken for 2 of them to fall is the same. They strike the ground at the same time. But we release the coconut 1 second later before we release the what? The the release the mango first and release the coconut 1 second later. So they're going to fall at the same time. Okay, for this one it was this 1 second later. So that means the time taking for this one to fall is what now? Is 4 minus 1. So what will the time taking for this one to fall? The time taking will be what now? Will be 3 seconds. So we have time, we have AY, that's to find the initial speed which is the second coconut was thrown. So looking for V naught. Looking for V naught, we can use the formula y equals to V naught t plus 8t square over 2. All right, what is my y? They both drop out from the same height, so y is also 80. So 80 is equals to v naught times, what's my t? 3, so 3 v naught plus, what is my a? A is still 10, so 10 times 3 square over 2. So 80 is equal to 3 v naught, 3 v naught, so give me 5. So 5 times 9, that will be 45. So take this over here, you have 80 minus 45. That should be 35. Yes, I think 35. So 35 equals to 3 V naught. So divide both sides by 3. My V naught should be equals to 35 divided by 3. So that will give me 11.67 meter per second. So V naught is 11.67, which is 11.7 meter per second. All right, next question. Next question. Um, Next question. Let's see what we have. We have a question here. Let's see this question. We're almost done with the question, so surprisingly. Let's see this question. What does it say? It says that a train travels with an initial, this is something simple now. A train travels with an initial velocity of 20 meters per second. So V naught, initial velocity, right, is 20 meter per second. So if it accelerates uniformly, acceleration uniformly at this, so that means the acceleration A is 2 meter per second square and travels 100 meter. It's traveling the x direction. A train cannot travel like this. Travel like this. So that means that x is 100 meter. Calculate the final velocity. This is very cheap. Final velocity in the x direction, obviously. So what formula can we use here? We'll be using the formula v square equals to v naught square plus 2ax. Okay, all these are in the x axis, but let's just leave that. We're not doing the projectile here. So v square will be equals to my v naught is 20. That will be 20 square plus 2 times 2 times 100. Okay, so v square will be equals to 400 plus 400. Is that 400? That's 400. So this will give me 800. So take your square root. So v will be, punch your calculator. What is the square root of 800? Okay, I got 28.228. That's 28.3. So 28.3 meter per seconds. 0.3 meter per seconds. So the answer here is what is A. Next question. So let's play with this one. So they said a train traveling along a straight line with constant acceleration of, okay, takes a time 4 seconds to cover a distance of this. So the distance the train covered, the x direction obviously, is 80 meter. It took a time of what, 4 seconds to cover that distance between 2 points. So the time t is 4 seconds. Okay. So if the speed as it passes the second point is this, the past second point, the speed is that's v is 30 meter per second. So what is the acceleration of the train? That's the first thing. Let's look for the acceleration of the train. What can we use? What can we use? Okay. We can use what formula? What formula can we use? So what's the acceleration of the train? We're not giving initial velocity, we're only giving the final velocity to be 30 meter per second. So we have formulas like v equals u plus 80. Will that be possible here? No. We have v square equals to u square plus 2s. That is possible here. That won't be possible as well. So what can we do? Can we find the initial speed first? Initial speed of the train, can we find that first? Let's see if we can find that first. So v is equals to v naught plus 8t. We have our t. We don't have our a, so we cannot find that first. But we can use what other formula do we have? We have s, and then s x rather is equals to v naught t plus 8t square over 2. Can we use this? No, because we don't have a and we don't have v naught as well. What about that one? Do we have v square equals to v naught square plus 2as? Can we use this? Can we use this? Can't use this as well because we're not giving the acceleration. So how can we solve this? How can we solve this? Any idea? What other formula do we have again that we have not tried? What formula have we not tried? Now we have this formula we have too. That one that says that x is equals to v plus u over 2 times t. Will that work? Will that work? So what formula will work for this? What formula will work for this? Now we're given, say, a train traveling along a straight line with constant acceleration. Okay, so how can we? So let's brainstorm together. The live section. Let's brainstorm together. How can we solve this? How can we solve this? Anybody in the comment section? Anybody in the? It's very clear. It's a very simple way to solve it. So let's just see. Anybody in the comment section have an idea on how to solve this? Nobody. Okay, well, let's solve it. So they said a train traveling along a straight line with constant acceleration takes a time that to cover a distance between that and that. Okay, so if the speed as it passes the second point, so that means that it started with, obviously it started with a particular velocity. Okay, so the speed at which it passes the second point is 30 meter per second. So for the first point, the 30 meter per second here is the initial velocity of that train. So if I use this formula here, I'll be having x equals to v naught t plus a t square over 2. So s now is 80 equals my v naught here is acting as my v now, which is 30 times my time is 4 plus looking for a, so a times 4 square over 2. So this will give me 80 equals to 120 plus 4 square is 16. So this will give me divided by 2, that's 8. That will give me 8a. So bring this, I will carry this to bring this over to the other side. So what will be our answer? Okay, is the body slowing down, or is the body slowing down or moving fast? I think this question is having, there's a kind of issue with the question. I think there's a kind of issue with this question. There's kind of issue with this question. Okay, but let's just solve it that way. Let's just solve the question. So I'll give me 80 minus 120 equals to 8a. So subtract, that should give us 40. That's minus 40 equals to 8a. So a is equals to minus 5 meter per second square. But there's no minus 5 meter per second square. So we have this and we have that. So let's find the initial speed. So how can we find the initial speed? Okay, so let's just say that means the body is decelerating. Okay, but that doesn't make sense from the question. Let's just solve it that way. To calculate the initial speed of the train. Initial speed as v naught. We go for v naught now. V naught of the train. What formula we go with this now? We have our v. Okay, that will give us 5 times 4, 15. Okay, if you look at it, okay. This, no, looking at the options, the one that has 5 is this one. Not one doesn't even have 5. This is actually velocity. Okay, so that means the answer is A. So automatically that makes A our answer. The question is not technically correct. There's some values that are not very clear, but that's the closest we can get to the answer. So real fast, let's solve the next question. Very clear, but that's the closest we can get to the answer. Alright, so let's solve this one. Let's solve this question. So a missile is launched at a speed of 50 meters per second. So V naught is 50 meters per second. So an angle of, what's the angle here? I think it's 45. I think the angle is 45 degrees. So theta is 45. Is it 45 or 40? That's 40. So 40 degrees above the surface of a warship. You determine the maximum height. So this is maximum height h. So we can use our famous formula that says that h is equals to v naught square sine square theta over 2g. So h will be equals to v naught is 50, so that will be 50 square times sine 40 all square over 2 times 10, that's 2 times 10. So h will be equals to 2,500 times sine 40. Sine 40 is 0.64278, and square that you have 0.41318 all over 20. So simplify that, multiply that by 2000, 2500, and divide your answer by 20. We're going to have 51.65. So 51.65. So the answer is A. Okay, so next question. Next question. All right, let's attempt this. Let's attempt this question in 10 seconds. Let's attempt this question in 10 seconds. All right, 10 seconds is up. So we have a car starts from rest. Starts from rest, so that means that initial velocity v naught is 0. A constant acceleration, okay, covering distance of, so distance in the x direction is 1200 meter in 40 seconds. So that means that my time taken is 40 seconds. Calculate. So calculate its velocity at this time. So we're looking for velocity of the body. All right. What else? What else? What else? What else? All right. So what can we do? What can we do? We're told covering a distance. We're told the acceleration of the body. We're not told the acceleration. So how do we find the velocity? Okay, we know that s is equals to u, or you can say v naught plus v over 2 times t. That will give me 1200 equals to 0 plus v over 2 times t. T is 40. So I break this down, I'll get 20. So 1200 is equal to 20 times v will give me 20v. So divide both sides. 0 cancel 0. 2 cancel that. You have 60. So my v is equals to 60 meter per second, which is option D. That's option D. Next question. Okay, let's see this. Say a car starts from rest and travels. All these are very simple. Why do I pack simple questions like it's in his past question or in his textbook? Okay, a car starts from rest. I thought I would be seeing better questions. A car starts. In case you have any question you want us to solve, you can just drop them on the comment section. All right, drop them in the comment section, and we are going to attempt them together. So a car starts from rest and travels. It starts from rest. That means that v naught is 0 and travels 250 meters. So x is 250 meter in 25 seconds. That means t is 25 seconds. I said at constant acceleration, calculate or find its final speed. So we're looking for final speed v. Similar to the last one, s is equals to v plus v naught over 2 times t. Okay, so that's 250 is equals to 0 plus v over, or anyhow, okay, I think I swapped the value. Let me arrange it properly. So v plus 0 times 25 over 2. If I multiply from here, I'll be having 500 is equals to v times 25. So divide both sides by 25. By 25, these cancel this. You'll be having 500 divided by 25. That will be 20. Okay, so that will be 20 meter per second. So the answer to that is A. It's A. All right. I'm seeing an interesting question now. Nice, 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 nice. This is a nice question. So we're told that, okay, I think I like this question. We're given x, we're given x, we're given x. Let me give a space. We're given x to be 2t square plus 4t plus 3. And we're given y. Let me do a color for y. We're given y to be 3t square minus 5t plus 2. All right. So what you have to find, so calculate the magnitude of the projectile's displacement and the average velocity between the time interval 2 seconds, and so we're given the time interval. So we have initial time to be 2 seconds and we have final time to be 5 seconds. We have to find the magnitude of the projectile's displacement, the magnitude of the projectile's displacement. All right, so in this case, this is acting on the x-axis. This is acting on the what? On the y-axis. So we can find the displacement on the x-axis and displacement on the what? On the y-axis. From there, we'll now get the magnitude of the displacement. Do you get the idea? So we'll find the magnitude, or you can find the displacement of this of the particle on the x-axis, and find the displacement of the particle on the y-axis. Then use the formula for resultant of a vector, which is, for example, if the vector is r, that will become r square. Are you following? R square equals to rx square plus ry square. I don't know if that makes sense. I don't know if that makes sense. I don't know if you understand what I just said. Do you understand? Oh, if you understand, raise your hand, please. Just give me a send an emoji or something. Let me know you understand. If you understand, let me know in the comment section. I'm waiting. I'm waiting. Okay, let's solve the question. All right. Some people have solved it already. All right, so we're given x and y, so we can find the displacement on the x and the displacement on the what on the y. I was waiting for a response, but I think no one responded. So let's continue. Okay, so here we are going to have for the x. Don't forget that displacement change means the right color. That change in x is xf minus xi. Don't forget that. So as to find xf, we can find xi using these values. If you remember the ones we solved initially. So for xf, that's when t is what 5 seconds. So let's put t into the equation. We're going to have 2 into bracket 5 square plus 4 into bracket 5 plus 3. So give me 25. 25 times 2 give me 50. 20 plus 3. So xf is 73 meter. So let's find xi. Xi is when time is what? When time is 2. So let's go. 2 into bracket 2 square. I'm putting t into the equation plus 4 into bracket 2 plus 3. So give me 2 raised power 2 is 4. That will be 8. 8 plus 8 plus 3. 8 plus 8 is 16 plus 3. That's 19 meter. So what will be the displacement here? Displacement here will be xf minus xi. That will be 73 meter minus what 19 meter. So when you subtract, you have 90. Sorry, 72, 73 minus 19. I went to press plus. You have 54. So 54 meter. This is the displacement in the x direction. Are you getting that? So let's get displacement in the y direction. In the y direction, change in y is equals to yf minus yi. So let's find our yf. Our yf is when time is 5 seconds. So that will be 3 into bracket 5 all square minus 5 into bracket 5 plus 2. 5 raised power 2 is 25 times 3. That will be 75 minus 25 plus 2. That should give me 52. 52 meter per second. Why my yi will be again I the initial time is 2, so let's put 2 into the equation. That'll be 3 into bracket 2 raised power 2 minus 5 into bracket 2 plus 2. So that will give me 2 raised power 2 is 4. That will give me 12 minus 10 plus 2. So that will be 4. 4. Is it 4 meter? Sorry, 4 meter, not 4 meter per second, 4 meter. So that's my yi. So my displacement in the y direction will be what now? Will be y f minus yi. That will give me 52 meter minus 4 meter. So change in y will be equals to 48 meter. So what is now they said the magnitude of the projectile's displacement. This is just the y-axis. This is just the x-axis. If you remember the time of vectors, when you are dealing with vectors, we have the x and we have the y. Now have a vector in between. So what do? Let's call the vector r. So you say r square equals to x square plus y square. Do you understand? So we can apply the same principles of um of vectors here. So the resultant, the resultant square is equals to this square and this square as 54 square plus 48 square. So resultant square is equals to 50 square. 54 square should give me 2916. 48 square should give me 2304. So r square will be equals to 5220. So r will be the square root as the resultant. This r means resultant of displacement. Okay, that will be equals to what? That will be equals to 5 square root of that. That should be 72.25 meter. Okay, 72.25. So that is option B. This is our answer. But if you want to confirm it to get, we have to find what now? The average velocity. So I think this is clear. This is the magnitude of what? Displacement. As magnitude, mag of displacement. Displacement. So we have to find the average velocity. Don't forget that V alpha is displacement over what? Over change in time. What's displacement here? We just got the value to be what now? 72.25. And what is the change in time? That's 5 minus 2. That will give me what now? That will give me 3. So the V alpha as average velocity will be equal to this divided by 3. That will be 24.1. 24.1. Let's see that's correct. Let's see that's correct. Yeah. Yes, that is very, very. Why am I shading it? That's very, very correct. So that is the answer to that question. Okay, so let's see the next one. Uh, rounding up. So let's see. Wow, we've come a long way. So let's see the last. Okay, we have just. I think we have two more questions and we are done. Let's see this question. It's a stone of mass. Okay, we're giving the mass of the stone and making it bigger so you can see. Okay, a stone of mass. The mass of the stone is 20 kilogram. It's thrown vertically upward. So the stone is thrown like this, vertically upward in that direction to attain the maximum height. So the maximum height from here to here is 20 meter. So the maximum height that the stone attain is in the y direction, right? That's y is equals to 20 meter. Calculate the initial speed. So we're looking for initial speed. That's v naught in the y direction. Okay. So don't forget that at maximum height, v at maximum height is what? Is 0. So with the stone, blah blah blah. Very very simple. So what is our a? Our a is ay, and that's g. But this in this case, now the body is going up. That'll be minus g, which is minus 10 meter per second square. So with the values, what can we use? We can use the formula, the normal formula v square equals to v naught square plus 2as. But in this case, now I'm doing the y direction, so this s will become y, this a will become ay, this will become y, this will become y. I don't know writing all those things. I'm just making sure that you understand what you are solving. So this one we have 0 equals to this here we have okay, I'm looking for it. Okay, that's what I'm looking for. Plus this here we have 2 times ay is minus 10. Okay, because the body is going upward. Then times y. What's our y? 20. So everything here should give me, this is minus 20. That will give me minus 400. To bring everything over here, it will become 400 equals to v not y square. So if you take square root of both sides, my v not y, because of the square root of 400, that will be 20 meter per second. 20 meter per second. So the answer here is A. Very fast, very fast. Let's see this question. So a boy throws a stone of mass 5 kg vertically downward. Okay, this is a stone. So this is a stone, and the stone is thrown, instead of it being thrown up now, it's thrown vertically downwards. So that means that A is AY and AY is G. Okay. Okay, it's not clear visually. Oh, I think that's just network. Okay, let me see what I can do. Just try to increase your resolution from your end. Try increasing the resolution from your end. Try increasing resolution from your end to maybe 720 and to be clearer. Okay. Um, said what else did they say? Downward the speed of it was thrown with this speed, so that means that V naught is 12.0 meter per second. So this is V naught y because it's in the y direction from a height of 30 meter to the ground. Okay, that means that that's the y. Y is 30 meter. Distances can be x, can be y, but in this case now we're doing in the y direction, so that's why I used y above the ground. How long does it take the stone to reach the ground? So I'm looking for time t. Okay, what can we use? We have v naught, we have y, you have t, you have a, and that will give me what formula can I use? I can use v equals to v naught plus at as usual again. Can I use this formula? Can I use this formula? Let's use something better. Let's use the formula y is equals to v naught t plus at square over 2. This is our y, this is our y. So v y is 30, so 30 is equals to it's still blurry. It's still blurry. Let me see what I can do. I think it's from your end. I think it is from who else is having that issue? Who else is having the same issue? Who else is having the same issue? Talk to me, please. If you're having the same issue, please let me know. So V not Y is 12. That will be me 12 times T. Okay, I'm looking for the T. So 12T plus AY is G. That's 10 times T square over 2. Oh, why is this leading us to? So let's use a better, let's use a different formula that only does that only does to a quadratic equation. So that formula that we have only does. I think this is the only one. No? Well, let's solve. Let's continue. So this will give me 30 equals to 12t plus 5t square. When you divide this, you have 5t square. Equal to 0. That will be 5t square um plus 12t then minus 30 equals 0. So if you solve this quadratically, you can just use a calculator to solve this. Okay, let's solve that. We have 5, we have 12, we have minus 30. Okay, so the values for t I got in decimals. T is 1.527, that's 1.53 seconds. And the other value is a negative value, so that means that cannot be the answer. So this is the answer for t. So t is equals to 1.53, 1.535. 1.535. Is it 535? Let me try. Let me check that again. Let me check that again. 1.52. Sorry. 1.527. Okay, this is seconds, not 5 seconds. So 1.5. What am I saying? 1.53. 1.53. 1.53. So which is the answer? You can see we have 1.54. You have to be very careful. The answer is 1.53. Okay, so it says you find the velocity before the stone or with speed just before the stone hit the ground. So we're looking for V. We're looking for V now. What formula can I use for that? You can use the formula V square is V naught square plus 2AY, right? So I'm looking for V. So V square equals my U is 12. That'll give me 12 square plus 2 times our A is G, that's 10, and our Y is 30. So V square is equals to 144 plus this is 20 times 30, and that's 600. So V square Abi is equals to 744. So take square roots of both sides. You see the square root of 744 is 27.27. 27 point, that's 27.3. So That affirms that B is the answer. So we are down to one last question. We are down to one last question. Oof, we've come a long way. So we're done with one last question. So let's solve that. Let's solve the last question. So the stone of mass 2 kg is thrown vertically upward the speed of. This is same as we have been solving since. So a stone of mass, whatever is thrown vertically down, is it upward or downward? Okay, upward. So this is a stone was thrown like this, was thrown upward. So what do we know? We know that A is minus G. It was going up. Okay. So calculate with what velocity with this speed. So that means that V naught in the y direction is 20 meter per second. We have to find the maximum height. At maximum height, V is what? Is 0. I already explained that. And we already know that A, that's AY, is G, which is it G or minus G? Is minus G, which is minus 10 meter per second square. Alright, so we're looking for the maximum height. So maximum height, that's Y. So distance in the Y direction. So what can we do? We have V naught, we have V, we have A, we have Y. So the formula for that will be what will be the formula? Help me out. What will be the formula? So that will be V square equals to V naught square plus 2AS. But now we're dealing with Y component to Y, 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 and Y. So let's go. This is 0. So 0 is equals to this here is 20. So 20 square um plus. So that will give me minus because of A is minus. So that will be minus 2 times 10 times Y is what I'm looking for. So that will be 0 equals to 400 minus 20y. So bring this over here. We're going to have 20y equals to 400. Divide both sides. This cancel that. 2 here will give me 20. So my y is 20 meters. My y is, okay, there's no option, but that's the answer. Y is 20 meters. Now, last and not in the least, we know that a basketball is thrown vertically upward with an initial speed of 20 meter per second. That's how easy projectile is. No matter how the question is on projectile, no matter how it is, you can always solve the question by using normal formulas for equations of motion. I wish I saw tougher questions. Maybe I'll look for tougher questions and send to the group or maybe solve some of them up here. So let's go. Say basketball is thrown vertically upward. Is thrown upward. So this is a basketball. Is thrown upward with a velocity with an initial speed of this. So initial speed V naught in the y direction again, because it's thrown vertically upward, is 20 meter per second. Calculate how fast as the speed. I mean velocity. It was traveling on its way down when caught 5 meter above where it is thrown. Okay, I like this one. When caught 5 meter above where it is thrown. So how can you solve this question? Anybody want to try? Anybody want to try? Want to attempt? So I'm looking for V practically. I'm looking for V here. Okay, so if it was, so let's use the diagram to explain. Here's the ball. It was thrown vertically upward to this point. Okay, said with an initial speed of that. That's the speed at which it was thrown. To calculate how fast it was traveling. It was traveling on its way down. When it's coming down now. When it's coming down. Okay, so when caught 5 meter above 5 meter, it was caught 5 meter above where it was what? Where it was thrown. So first we can find the time taken for it to come up. Well, in the second statement, we're talking about how fast it is when it was coming down. Let's find the time taken for it to go up first. So let's find the time taken t. Now A is minus G, obviously. So my formula is V square, that's Y, equals to V naught square, that's Y, plus 2AY. We're given distance in the Y direction. We're given distance. We're not given distance, right? So let's do something else. Yeah, we're given a distance. We can find a distance actually. We can find, instead of finding the time, we can find a distance. This is a better way. Okay. So let's go. My Vy. Okay, we don't have our V as well. Okay, but it went to maximum height, Abby. So that means that when the body was going up, it stopped at maximum height. And at maximum height, V is what? Zero. So let's start with that. So this is zero. Alright, so let's deal with the fact that it is going up. But now deal with the fact that it is coming down. Do you understand? So let's go. So be 0 equals to 20 square. It's going up, so A is minus G, that's minus 10y. So 0 equals to 400 minus 10y. So 10y will be equals to 400. So y is equals to what? Break this down. That will be 40 meter. That means that the height, that means from year to year. Let me clean and make the diagram better so you understand. From where the ball was thrown to the maximum, this is the maximum height. From year to year is actually how many meters again? Is 40 meters. Is 40 meters. Do you understand? Now I'm talking about, let's now go to the second statement where they said calculate how fast it was traveling on its way down. And when the ball is coming down, let me have this power off. When the ball is coming down now, let me that straight. When the ball is coming down, at this point where it is coming from rest. That means initial velocity is what? Is zero. That's one. A is coming down now. So A is no longer minus G. But A is now what now? G. Do you get? What else? We're looking for the velocity of the ball, of the body of the basketball or the baseball. So we're looking for Vy. But in this case, okay, someone said there's a mistake. Okay, where is the mistake? Where is the mistake? Vertically downward means Y direction, not X direction. Y direction. Okay, someone said there's a mistake. Did I make a calculation mistake? Where help me out, help me out. Where is it? Okay, I think I've seen that. Okay, that's 20, right? 20. Sorry. This is 20. This is 20, not 10. All right, thank you. That was a typing. That was I want to say typing error. That was a math error. So this is 0 equals to 20 square plus 2. This is 2 times 10. That's 20. This is going to be minus 20y. So 0 will be equals to 400 minus 20y. Isn't it? So when you bring this over here, you have 20y equals 100. 0 cancels 0. So we're going to have y equals what now? Y equals to 20 meter. So my distance here is 20 meter. All right, thank you for this for seeing that. Okay, so what was I saying? I'm looking for Vy, so the velocity that the body is used to come down. But now I said they cut this body. Where they catch it? They cut it 5 meter above where it was thrown. It was thrown from this point. Where's a different color? It was thrown from this point like this. So now cut it 5 meter above. From here to here, like it was cut from here to here is 5 meter. So it was cut from where to where? From here. So that means from here, if here from here to here is 5 meter, and here to here will be what? 50 meter. Since everything is what? Since everything is 20 meter. Do you understand? So the body is coming. So the body is coming from up. It's coming from up down. So if it was cut here, that means that the body traveled how many? What was the sound that the body traveled? Only 15 meter. So therefore, y is what? 15 meter. Let me include that here. So therefore, y is 15 meter. So if you solve, I don't know if that's clear. If it's not clear, please talk to me. Talk to me if it's not clear. It was caught 5 meter above the ground. Above the ground. If the total distance it traveled was 15 meter, 5 meter above the ground, and the body have traveled 15 meter before it was caught. Do you understand that? So that means y now is 15 meter. Do you get? So we have to find how fast. We're looking for v. So what's our formula? What's our formula? We can use the formula v square equals to v naught square plus 2as. But now we're dealing with the y direction. So 2ay, y, and y. Are we getting that? So what's vy? This is what I'm looking for. What is my v naught? My v naught is 0. This 0? Yes, 0. So this one is 0 plus 2 times this is 10 because it's coming down. So it's equals to g. That's 10 times 15. So vy square will be equals to 20 times 15. That should give me 300. Is it 300? 20 times 15. Yes, that will give me 300. So take square root of both sides. My vy will be equals to the square root of 300. That's 17.3 meter per second. So that should be the velocity. You can check your Adewale physics and check the back and see what the answer is. That should be the velocity of the body if it is caught 5 meter above the ground. So the answer is what? 17 point. The answer is 17.3 meter per second. Okay, so finally, we are done with all the calculations. Maybe I'm going to connect on that class for other calculations. So what I want you to do is the most comment I receive on this video will be our next topic. Drop drop your comments. So drop your comments. What topic in FSC 115, that's physics, and FSC 112, that's chemistry, or 111, whatever, do you want me to treat next? So simply drop that on the comment section. So thank you guys for joining the live stream. So we'll see you some other time. For the new student joining us, please don't forget to like and subscribe. That is the way we generate our own revenue. All right, the class is a free class, so the way you generate our revenue is through your like and your subscribe and your subscription. So